Good morning. I am Mrs. Axel Jovita, Assistant Professor, KCS Kasinada College of Arts and Science. In this video, we are going to discuss about Introduction to Stack. Topics which we are going to cover are Stack, implementation of Stack data structure, and some basic operations, and analysis of that operations, and application of stacks. What is stack? Stack is also similar as array, and it is used to hold some collection of elements of same data type. In computer science, we can say a stack is an abstract data type. What is that abstract data type? Abstract data type is a type of objects whose behavior is defined by a set of value and a set of operations. The definition of abstract data type only mentions what operations are to be performed by, but not how these operations will be implemented. It does not specify how data will be organized in memory and what algorithm will be used to implementing the operation. It is called abstract, and the working concept of the stack is last in first out principle. It means last entered item removed first. A most popular example of stack is plates in marriage party. First plates are pushed onto the top of the pot from the top. And here's the live example of stack. We have some of the plates here, and we are arranging the plates on top of each other, that is pilling it. This is the working concept of stack. Stack can be easily implemented using an array or a linked list. Arrays are quick to access but are limited in size. Linked list requires overhead to allocate, link, unlink, and deallocate it, but it is not limited in size. So we can apply the stack structure as we need. This is the image of stack implemented as array. Here we are having three elements, which is 70, 80 and 10. We have to insert these three elements into our stack. Initial value of the top is -1. That means now the stack is empty. So if I am inserting the 70, after that I want to insert 80, and after that 10. Like this, we are inserting our element on top of the each other element. Here is the example image of a stack implemented as linked list. So all we know, list have number of nodes, and each node has two parts. One is to hold data and another one is to hold address of that next node. This is the structure of the list, all we know. So here we are having the stack element 9, 4 and 7, and it will start from the head node, which is addressed by 6040, that is 6040, and this is the address of the next node. So here we are holding the number 9, and this node is holding the address of this next node. Okay, this is 4500, and here we are having the element 4, and in the address and this node is holding the address of the next one, which is at 7000 here, so that we are having this address and here, and at the address of 7000 the number 7 is placed. No other elements in our list, so last node is mentioned as null. That is the end of our list. So like this, we are using that stack element and representing the stack element as linked list. Next, what are some basic operations on stack? So there are two main basic operations as push and pop. Whenever we are doing that push and pop operation, automatically we will include isFull and isEmpty operations also. And the one more operation is peek. Get the top data element of stack without removing it is the use of that peek operation. Here we are going to discuss about one push, pop and isFull and isEmpty operations. Next, what is push operation? We can perform the push operation using three steps. Check if the stack is empty or full. If the stack is full, then print overflow and exit from the program. If the stack is not full, then increment the top and add the element. So doing the three steps, we can perform the push operation. Here is an example of push operation. Insertion of item in stack is called push. In stack, any item is inserted from top of the stack. When you insert any item in stack, top will be incremented by 1. Okay, this is the insertion operation. Here is the coding to perform the push operation. In this operation, first we are checking the top value to check the condition whether my stack is full or not. If my top value is maximum, which is equal to maximum size, or which is greater than maximum, then I will print my stack is full. Else I will add top is equal to top plus 1, and then I will get the element which is want to insert into the top. It will be 10, and then I will take the top 10 into my stack top. Okay, this is the coding for inserting an element into the stack. Next is the pop operation. So as like push, we can perform this pop operation using three steps. For that, check if the stack is empty or not. If that stack is empty, then print error of underflow and exit the program. If the stack is not empty, then print the element of the top and decrement the top. This is the three step we can use to perform the pop operation. And here, deletion of any item from stack is called pop. In stack, any item is deleted from top of the stack. When you delete any item from stack, top will be decremented by 1. This is how the pop operation is performed in our stack. Here is the coding for pop. First, we are checking the top value, which is equal to -1. If it is -1, I will write the stack is empty. Initially, all we know, the stack can hold the top value as -1. If my stack is empty, from that stack I can't delete any element. So I just throw the error message or the message like stack is empty. If it is not empty, that means my top value is not equal to, top is not equal to -1, means it's holding some 0 or 1 or 2 something, whatever it may be. Okay, then what I have to do is I just simply pop the element and top is equal to top -1. If my top is here, it is 1. 1 means I am having the 10 inside the top value. If my top is equal to 1, then immediately I can the element the 10 from the stack of, because as per the working concept of stack, I can delete the top element only. So after the deleting element, my top value will decremented to 1, that is top is equal to top -1. Using this code, I can perform pop operation in our stack. Next, analysis of stack operations. The time complexity for various operations that can be performed on stack data structure. For push operation, it is big O of 1, and the pop operation also big O of 1 for top operation and the search operation, and we have O of n. So the time complexity for push and pop functions are O of 1 because we always have to insert or remove the data from the top of the stack, which is a one-step process. So we are having only a big O of 1 as our time complexity. Here are some application of stack: parsing, recursive function, calling function, expression evaluation, expression conversion, and maze problem. In next class, we will going to discuss about all these applications. Thank you for watching.